comments to the board and an item that's not on the agenda, now's the time to do it. Item number 6A1, adoption of agenda. Board order 6A1 would be in order.
Mr. President, I'll move an approval of the agenda.
Motion by Director Marcy,
Second.
and second by Director Van Dam. There's no further questions or comments. Madam Secretary?
Audrey Miller,
Yes.
Robert Paris,
Yeah.
Jay Tremblay,
Yes.
Keith Dias,
Yes.
Drew Lindsay,
Yes.
Gary Van Dam,
Yes.
George Lane,
Yes. Motion carried. Thank you. Moving on to the next item, number 7, consent calendar. We have 3 items. All of those are regarding the minutes of June 10th, June 24th, and July 1st. And Ben's had a chance to review those, but the motion would be in order.
Can I make a motion? I'll make a motion
Okay.
to adopt that.
Jay, thank you. We have a motion.
Second.
Second by Dr. Van Dam. There's no further questions or comments on the minutes. Motion, roll call.
Audrey Miller,
Yes.
Robert Paris,
Yes.
Jay Tremblay,
Yes.
Keith Dias,
Yes.
Drew Lindsay, Gary Van Dam,
Yes.
George Lane,
Yes. Motion carried. Moving right along. The rest of the agenda is not part of this evening. Okay. We'll move on to the next item, item number 8, Finance Committee. And Director Dias is chairman of that committee, and we'll turn it over to you.
Yes, thank you, Mr. President. The Finance Committee met last Thursday, and among the things we discussed was the check register list for the period of July 10th, 2025 through July 30th, 2025. And we will recommend approval at the appropriate time for the corresponding board order, but I believe first, our General Manager Newton has a report for us.
All right, thank you, Director Dias. Good evening, board members. Beginning on page 21 of your board packet is the check run for the period of July 10th through July 30th. This was reviewed by the Finance Committee in detail last Thursday at their regular meeting, but I'll hit just a couple of the highlights. Item number 1 is our monthly variable payment to DWR for moving about 8,873 acre feet of state water project through the aqueduct to AVEK. Comes out to about a little over $200 per acre foot, and the total amount is just under 1.75 million. Most of that water was delivered to our banking facilities, but a pretty good portion was also used here at the Port Hill Water Treatment Plant. Item number 12 is a pass-through cost for boron CSD. That's based on the wheeling agreement we have with boron and with Edwards Air Force Base, and that covers a 3-month period to wheel water through their system. And President Lane, I think you had a question on that at the Finance Committee, and I've got some information to share with you later.
Thank you.
And if you move on to page 23, you can see item number 50 is our annual membership dues to the state water contractors. That was approved by the board, part of our membership list, and it's a little over $330,000. Also, I think President Lane requested some detail out of the State Water Project Committee on that, and I do have the information from the state water contractors, and I'll share that with the committee and board.
Thank you.
Moving on, nothing else really jumps out on the AVEK check run. If you look at page 27, we have 5 invoices associated with the High Desert Water Bank Capital Program, all of which are reimbursed by Metropolitan Water District. Just under $430,000 total. A good portion of that is a progress payment to Bakersfield Well and Pump for drilling package number 3 that we're going to hear more about this evening in detail. And then the last page is also associated with the High Desert Water Bank. And these are costs or expenses associated with our operation and maintenance of that project. Also, all of these costs are reimbursed by Metropolitan Water District. And the total is just over $3,300 or $3,200 for this period. And with that, I'd be happy to answer any questions you may have on specific items.
Just a comment, you know, Matt, like we showed the tire store $20. And would it not be feasible to have an overhead cost, so we wouldn't have these little costs in there? Maybe that's not how the contract reads, but just a comment, your thoughts on that.
So the agreement with Metropolitan spells out that they shall cover all direct expenses associated with the project. And so they cover all the staff time, which includes our fully burdened rate of staff, inclusive of benefits and payroll taxes, retirement, etc. But then it gets into itemized actual expenses. On top of that, there is a provision where they pay a percentage of our, Teresa can correct me, G&A expenses or budget for the agency, and that covers things that we really can't track on a dollar specific basis, like our general insurance of the agency. That's the big one that comes to mind. Insurance, lights, building, etc.
I understand if it's working, that's fine.
Yeah, it is working good, and these are all reviewed by Metropolitan Water District.
So I had a question, Matt, on the Bakersfield well and pump of $218,452.50. Is that the last payment to them?
That is not the last payment. Justin's going to talk about that under an action item later. So this is a progress payment. The final payment will be their retention payment. So on every progress payment, we withhold 5% into retention. And when the project's all done and we ensure that there's no claims or liens against the contractor, then we release the 5%.
Okay. Then we go out to bid for the 7 wells?
Yeah, we'll go to public bid based on the public contracting code. Get bids on that.
Okay.
Yep.
Thank you.
You're welcome.
Does that conclude your report?
It does.
Again, we have a committee recommendation of the finance committee, and the board's had a chance. If there's no questions or comments, I guess motion would be in order. Right?
I'll make a motion, we approve board order 8A1, this is Keith.
And Rick, should I ask for the motion?
Mr. President, I'll second.
Okay, Mr. Mercy, in the motion and the second, is there no further questions or comments? Madam Secretary?
Audrey Miller,
Yes.
Robert Paris,
Yes.
Jay Tremblay,
Yes.
Keith Dias,
Yes.
Drew Mercy,
Yes.
Gary Van Dam,
Yes.
George Lane.
Yes. Motion carried. Yeah, thank you.
And the finance committee also discussed and recommend for board approval a purchase order in the amount of $65,086 with Southwest Valve and Equipment for valve replacement at Clearwell number 1 at the Quartz Hill Water Treatment Plant. And I believe our operations manager, Bozigian, has a report for us.
Thank you. Okay, so this is an overhead view, aerial view of the Quartz Hill plant. You can see our clear well here. Where to work. There's a clear well. These 2 stars are the influent and effluent valves where water goes in and out of that tank. Those are 42-inch gear-operated butterfly valves installed in 1975. And we had looked at replacing these valves over the last several years because they don't seal anymore. We're gonna have some work done on this clear well, so we really need to be able to isolate it and drain it and let the contractor get in there and do some work on it. So included in our 2025-2026 budget, we allocated $70,000 for purchasing 2 valves. And there's also $500,000 allocated for the excavation and replacing of these valves. But tonight we're just talking about us purchasing the valve rather than a contractor purchasing them. So we went out to 3 valve suppliers. Gary, we went out to Rain for Rent to make sure, you like to make sure we don't exclude them.
Thank you.
So we went out to Rain for Rent. We went out to R&B Automation, who has supplied a lot of valves. And Justin and Joe Roberts found Southwest Valve Company, who actually, by Pratt Valve, who we're going to replace with Pratt Valves, that's one of their suppliers. That's one of the ones they recommend. So we got 3 bids for these valves. R&B was $127,492. Rain for Rent was $125,869. And Southwest Valve was half of that, $65,086.08. So credit to Justin and his group for tracking that down. Apologize over the years, we've probably overpaid for valves, but who knew? Anyway, these are very special valves, very, very odd size, 42-inch valve. It's not a standard size. So we're happy that we found those. And we will come back to tonight we'd like to recommend approval of Southwest Valves, purchasing these valves. And then Justin will come back in the future when we actually put this out to bid and are gonna do the replacement, which we're looking at sometime in March to actually do the replacement. So be happy to answer any questions.
So I had a question. Have we always got the bid ourselves on those valves, or have we went through a contractor to get the bids?
Typically we like to purchase valves ourselves. We get them much cheaper. Contractor's gonna do a markup. So typically on projects, we will purchase the valves ourselves, unless it's a big contract, for instance, like the DVP contract that we did. There was multiple valves being replaced, and that was just part of the contract. But Gary, usually we purchase them. Anytime we can do that, we'll do it.
And then also this third bid that we got that's so much cheaper, where have they been before? How long? They've been around, or?
I don't know. Backing me into a corner here. I don't know.
Good job, Justin.
Yeah, so, but they're, legitimate valve company, and Pratt they're one of Pratt's supply.
Same model, same style, I mean, not.
No, I mean, we put out the spec to all 3 companies.
Right.
And they sent back their proposal that meets that spec. The bearing service valve, these valves are 20 feet deep. So, pretty tough to replace them.
Right.
But yeah, no, this is the same valve. So we will keep Southwest Valve in mind in the future for sure.
Good job, guys.
Just a question, do you have any idea why there's such a difference?
George, the only thing I can say is typically when we see suppliers that are a lot cheaper than others, it's because they move a lot of product. It's like the Costco business model. They don't need to make a lot on each sale because they make so many sales.
I know I asked you the question before, but do these people physically manufacture it, or do they buy it from
They do not manufacture. Pratt manufactures the valves. And so they are just a supplier, for these valves.
Thank you.
I think a lot of times they see the name AVEK and
That's
certainly
possible. I think.
there's a big difference there.
We've seen that in the
looking at
past.
twice the amount of money.
Right.
So just bear that in mind.
Right.
Good job, guys.
Thanks.
Okay, is there any further questions or comments from John? If there's no further questions or comments, a motion would be in order. Director Paris? Did you so move?
I did not.
Were you thinking about it?
I'll be happy to make a motion, Mr. President.
We have a motion from Director Paris. We have a second.
I can second.
Do you think I'm not participating enough?
Okay, thank you. We have a motion and a second. Madam Secretary?
Audrey Miller,
Yes.
Rob Paris,
Yes.
Dave Tremblay,
Yes.
Keith Dias,
Yes.
Drew Mercy,
Yes.
Gary Van Dam,
Yes.
George Lane.
Yes, motion carried. Yeah, thank you,
Thank
everyone. Good job.
Good job, Josh.
Mr. President, what if I wanted to abstain on that?
Anyway, we'd still be here. Okay, thank you. Moving on, good.
That concludes the finance committee report.
Yeah, thank you. And we'll move on to item, 8B in, Director Dias, you're also chairman of that committee. High Desert Water
Yes,
Bank.
yes, thank you. The High Desert Water Bank Committee met, July 24th. And among other things, we, heard a presentation on the High Desert Water Bank well drilling activities. And I believe that that same presentation is going to be presented to the full board tonight.
Okay, I think we're ready, and you can just introduce yourself, please, and
Sure.
proceed.
Good evening, board members. My name is Tim Leo, and I am a hydrogeologist at Montgomery Associates. And Montgomery Associates is a hydrogeology and water resources firm, and we are working on this project. In fact, we've been working on this project for almost 10 years, back when it first started.
And you did the presentation for
I
it.
did the presentation, yes,
You did a very good job.
Thank you for that. And so, so we're a subcontractor to Stantec Engineering, and Joe's here tonight. And we've been doing all the hydrogeology work on this project. And tonight we're going to talk about kind of the recovery well field. And, as everybody is aware, this is a recharge and recovery project. And so we're well along on all aspects of the project. But tonight we're going to talk about the recovery well field and where we're at on that, and how we arrived at where we're at and what do we learn. And I think it's a good story that I think everybody's going to agree that we've made some really good progress in building the well field. And we've approached this well field, I think, in a very prudent way of alternating between drilling phases and groundwater modeling work. The groundwater modeling work is a tool we use to kind of predict the future, if you will, based on the information that we're learning in the field. And I think we've taken a pretty measured and effective way of building the well field out in a cost-effective means. And so we're going to talk about what we've learned in the last 3 drilling packages. We're through 3 drilling packages now. Drilling package 3 finished up earlier this year. And that's, will be part of the focus of tonight, is talking about what we learned all along and what we learned in drilling package 3. So what do we do in the field? What's our role in the field? And tonight, this presentation will be a condensed version of what we gave to the High Desert Water Bank Committee, so we're going to go by time slides tonight. So what do we do at M&A? Well, like I said, we're hydrogeologists, so our role in the field is really to coordinate the activities in the field, and we're only there during critical phases of the work. And one of the key aspects of our work is we write very detailed technical specifications for the work, and that outlines every aspect of the work in a high level of detail. Those tech specs are provided to the drilling contractor. The last 16 wells have been drilled by Bakersford Well and Pump, and they have learned our specs very well and follow them very closely. So our job in the field has been generally pretty easy. So we're out there making sure that the work is being done in compliance with those tech specs. So we're there to document and observe what's going on. And then if there are any issues, and we've had luckily so few issues on this project in the 20 wells we've drilled to date, that there haven't been a lot of issues to resolve. But if there are issues, we're out there as the eyes and ears of AVEK to make sure that we know the story behind those situations and can help AVEK resolve those with the drilling contractor. And then once we get the information from the field, we design the well and provide that well design to AVEK for approval. And we'll talk a little bit more about that in a minute here. Like I said, we're there to observe what's going on in the field. And then we follow through after the wells are built, test the wells, get some data from those wells, analyze those data, prepare a report. So we'll, like I said, we've made very good progress through the well field to date, and we'll talk more about what we've learned. So what happens when you're drilling a well out here? This picture on this slide here shows one of the well sites, HT20. This is the drill rig and the equipment, the support equipment up on the H20 drill pad. So you can see the drill rig mast there. So during the well drilling, there's a lot of steps. It's a multi-step process, a multi-month process that takes place to drill the wells. And so the first thing we do is put a conductor casing in the ground. We come back in there, we drill through that conductor, and we drill a pilot borehole down to 1,200 feet. And we log that borehole, figure out what the geology looks like at that location, and from that we design the well. That well design is then provided to AVEK for review. The well design at this far into the project is simply the depth of the well and where we're going to screen that well based on the geology at location. We early on in the project we standardized other aspects of the well design, like the casing diameter, the casing material, the openings in the screen. All that's been standardized. That was done to make the project go more efficiently and expedite the process. Once the well's constructed, before the well's constructed, we read that pilot hole to the full diameter of the borehole needed to put the well in the borehole. We construct the well in the borehole, and then we develop the well. Well development is a critical step in building wells. If you don't develop your wells fully, those wells are not going to be, they're not going to perform as well. After we finish the well development, we test the well, and then we run some final surveys, disinfect it, complete the wellhead. So it's a multi-step process that occurs in the field, and we're only there during certain phases of the work.
What's the geophysical survey? What's that?
The geophysical survey, what that is we bring a specialized contractor. I'll show you a picture of that in a minute. We bring a specialized contractor out and we run some tools down into the borehole, either the pilot borehole or the actually completed well. And we run some electric logs, and that allows us to see the profile of the stratigraphy at that location. And we look at that stratigraphy, and that's how we really design the well. We look at, and it shows us where we've got fine grained materials and coarse grained materials. And this, out at the high desert water bank site, we have alternating sequences of coarse and fine materials. So we study that log there. We also have a physical log, and I'll show you a picture of what we collect for that. So we have a physical log of what's going on, actual material. And all that information is used to design the well and figure out where we want to put the screen. So this is a slide that summarizes what we do in the field to design, to construct the actual wells, which obviously are the product we're looking for. Now I'm going to go through some pictures of what we do in the field here. You can see on the left-hand picture here, we have a picture of the pilot drill bit. You see it's a 17-inch bit. So these are big wells. These are big drilling operations. So that's the drill bit we use to do the pilot borehole, which is what we log, geophysical log, to get the information we need to design the well. You see in the middle of the picture here, this is what we call a chip tray. So this is actual physical samples of every 10 feet of subsurface we drill through. So we collect those and have those as a record of what we observed there to go back to the office. And we log them in the field, but we then check them in the office oftentimes. And this gives us a physical look at what's underneath the ground at each of the locations. It's critical for designing the well. And on the right-hand picture here, you see the geophysical logging truck that comes out to the field, and that truck comes twice. When we log the borehole, and then once we've completed the borehole, we do some additional testing in the well. And so that's just one of the specialized contractors we use to help the well design. These pictures here show bits and pieces of the well construction. So the left-hand picture here is a picture of the well screen. It's got the centralizers that the well down to the screen there. You can see those will keep it in the center of the borehole. This is a picture of the louver casing that we put in there. That's the open slot well screen. The middle picture is the drilling contractors installing the gravel pack, which is the material that we put in between the angles, between the walls of the borehole and the screen. That's basically a filter pack to take out fines as the well pumps. So that's a picture of them installing the gravel pack using a Tremie tube that goes down the annulus of the borehole and then we bring that up through the entire screen interval. And on the right-hand picture here, again, one of the critical steps is us checking the water quality during development to make sure that water is clean and has low turbidity and low sand content. You don't want to pump sand into your pumps, so we make sure that well is fully developed before we stop the development process. One of the most important steps, as I said, in the process.
So I had a question on the gravel pack. How thick is that?
Boy, it's a good question. See, the bottom part of the ream is 26 inches diameter typically, and the well casing is 18, so the annular space is about 8 inches.
Right. Okay, so it's an 18-inch casing?
Yeah, it's an 18-inch casing, and I think we telescope that the ream starts at 32 at the surface, I believe, and telescopes down to 26 inches at the bottom.
I see. And our bowls are sitting at about 650 feet.
Yes, we have, as we talked about in High Desert, committee when we showed more slides, yes, we have a blank, that's a blank casing section that's situated in the middle of the screen, typically middle bottom of the screen. That's where we'll put the pump holes. And that was designed it's for that purpose alone, and it's usually pretty deep here, because we have to allow for a lot of drawdown when we pump people up. We're gonna pump a lot of wells in a small piece of property here.
So in time, if we had to, because these wells are drilled at 1,200 feet.
Most of them are almost down to 1,200.
Okay. So we could always drop the bowls.
Yeah, you could if you wanted to. I mean, I think we've designed these so that pump blank, or that pump chamber, we call it sometimes, is deep enough that'll be kind of the permanent set depth. We won't typically draw down to that depth.
Well, until you kick them all on.
Well, we accounted for that in our analysis. We know at least so this slide here shows you what we knew after drilling package 2. And you can see the map on this slide shows the locations of the wells that were drilled in drilling package 1 in blue and drilling package 2 in red there. And you see we had 10 wells in after drilling package 2. This is the summary table of what we learned for those first 10 wells. And you can see on the bottom there are averages for the numbers on this table. I won't go through every one of these. You can see after drilling package 2, the average depth of the wells was almost 1,100 feet. Wells had averaged about 607 feet of screen in it. Specific capacity is a measure of how productive the well is. It's a measure of how much water can you take out of the well in gallons per minute for every foot of drawdown you created in the well. It's a typical measure that we can look at well to well to compare how productive those wells are. And you can see that in this case, the average is about 13 gallons per minute per foot. So for every foot of drawdown you create on average in the wells, you're getting 13 gallons out of the well with that measurement. And you can see on the last column in this table that we run, after we analyze the data, we estimate what we think this well will pump if it was the only well pumping on the property. So those numbers in the right-hand column here show you our estimate of the sustainable pumping capacity of the wells, like I said, as if it was the only well that's pumping. In reality, we know that in the future, when we recover groundwater from the project, we're likely to operate most, if not all, the wells at the same time. So those rates you see here will not be the rates that these wells will operate at when you operate all of the wells, because the wells are all going to compete with each other for the same groundwater, and you're going to create drawdown, and the pumping rates are going to drop over time.
You just elaborate a little bit more. We said 13 gallons for every foot of drawdown. Was that?
Yep.
I don't quite understand that. It's going to be the well pumps. I mean, usually not that much drawdown on a well. Those are doing the pumping.
There will be. So what's going to happen here when we so if you just pump one well, you're right. The amount of drawdown it may not be all that much. It might be maybe 100 feet drawdown, maybe not even that much, perhaps. And you can see that if a well is pumping at 1,300 gallons a minute, you have a specific capacity of 13, you would have had, my math is right, 100 feet of drawdown. So therefore, but what's going to happen when we pump all the wells in the site, when we're recovering water in the future during operation, is there's going to be a lot more drawdown. And that's why we need to put the pump so deep in the wells, because each of the wells are going to compete with each other. And so specific capacity of 13 is a bit higher than we expected for most wells. And we'll show you what we learned in DP3 in a minute here, and then we'll summarize what we know in average conditions. And things have gone very well in the field as we reported to the committee. You can see after DP2, we had an average estimated capacity of 2,300 gallons a minute roughly, which is a good number. So this is what DP3, so DP3 was 10 wells. So drilling package 3 was 10 wells, and those are the wells in green on this map on the left-hand side. So in this drilling package, you can see that the wells are of similar depth, averaging about 1,100 feet for the average well depth, and there's a range on that. Screen length similar, 670 feet, 660 feet of total screen on the wells. Specific capacity a little higher at 15, and the average pumping capacity now is nearly 2,800. Yes, an estimated pumping capacity.
I had a question.
Yep.
On that screen, is that two different levels? And there a blank in between those screens?
There is, right. And to keep the presentation a little shorter tonight, we decided to take that slide out, but you're right. there's an upper screen
Okay.
separated by a blank section and then a lower screen.
Yeah, explain to the board.
Typically what we do there is, you know, our pump blank that we put it, so there's an upper screen down to this blank section in the well. I should have had the picture here, but you know, that blank section is typically down, say between 650 and 750 feet below the ground.
Big volume.
There you go. So, all sending messages here. But anyway, that blank section there is typically anywhere from, you know, 40 to 100 feet in length, that section there. And below that, there's screen interval as well. And that's where we're going to put our pump intakes, in that section. And that also gives us another possible operating condition in the future, if we needed to consider it, is that we could packer off that blank and isolate the upper screen and pump just from the upper screen if we need to. If we have water quality issues in the field, for example, as we go in the future, we might be able to packer off that in that blank section to eliminate the contribution from the lower screen and only pump from the upper screen. That might help water quality. That's something we don't anticipate based on our analyses, but there's another reason that pump blank might be handy.
Okay, so basically where the bowl sit, it's in the blank.
It's in the blank. It'll be in the blank. Yeah. We want to basically minimize, you know, the energy from the water coming in the screen, those to just level pump, operate better and cooler. So, so that's how we design all the wells have a pump blank in them, and we'll summarize in a second where we're at in terms of all the wells we've drilled now. But you can see in drilling package 2, things look a little better. You see now the average yield for these wells, estimated yields almost over 2,700 gallons a minute, which is certainly higher than we expected when we started on the project based on the drilling information we had.
What do we expect?
We started out this project, and let's go to the next slide. We'll talk about that. So this slide here is a table that summarizes for all the wells. There's a little note at the bottom there that we haven't analyzed 2 of them yet, but to date we've drilled 20 wells, and you can see what we know now. So we started out the project with an estimate of 1,800 gallons a minute per well we were going to need to achieve the goal of 70,000 acre-feet per year of recovery capacity. And if you do some calculations, you'll see the 1,800 is actually more than you would need to get to 70,000, but we anticipated we're going to need higher than that, just to account for the idea that there's going to be, the wells are not going to operate at the estimated sustainable yield that we talked about, because there's going to be well interference effects. So as you pump this well field, the well pumping rate is going to go down over time. So we started at 1,800 as our design goal for the site based on the information we had at the time. And you can see where we landed in the 4th column on this table here, the 5th column actually from the left, is the estimated pumping capacity, is the average so far from 20 wells, about 2,500 gallons a minute. You can see that for per well, if it was only well pumping, our estimate is about 700 gallons a minute more than our design when we started. So overall, the wells at the site have been proven to be more productive than we anticipated, which is good news that we're not going to likely have an issue with meeting the recovery capacity goals of this project. But bear in mind that we've yet to finish all the wells, equip them, pump them all at the same time. So when we do that, we're then going to finally learn what this well field will do when we have all the wells operating at one time, which will be a condition that will likely occur in the future. You can see that one of the wells we estimate can pump over 5,000 gallons a minute. There are a couple of wells out here that are up in 4,000s and 5,000. It's kind of crazy how it varies. You can see some of them are as low as 1,400. So you see there's a lot of variability. That even on a small piece of property like this, you move over a quarter mile, some of these well pumping capacities vary quite a bit. It shows you how variable the geology is at this site. But overall, on average, we've done very well. The columns on the right of this table, the arsenic and nitrate concentrations I added in here because treating the water is going to be needed to put it back into the aqueduct. So these concentrations here, the average arsenic concentration runs at about 14, which is above the federal maximum contaminant level and the state MCL for drinking water at least. And so those two constituents, nitrate and arsenic, are the ones that Metropolitan is focusing on for their treatment. as needed to put the water back into the aqueduct. So overall, it's a good story. I mean, we have proven now after 20 wells that the average pumping capacities of the wells out here exceeded our expectations, and therefore we pretty much eliminated the uncertainty that we're going to be able to meet the recovery goals of the project. But again, we haven't actually pumped all of them yet at one time. So that's kind of a good news story, I think, in terms of what we've learned since we started out there. So to summarize here, we built 20 of the 27 wells early in the project. We did some analyses with our groundwater model and have improved that along the way. We've arrived at 27 wells that we're going to construct out there to ensure that we can meet the goals. We've got 20 of them done now, 7 more to go, and we're going to talk about drilling package, next drilling package tonight, I think. For each of the wells, we write a report, a nice, fully comprehensive report for each well. We provide all the data we collect to the AVEK team so that everything is documented in the files at AVEK. We've got 10 more to write for drilling package 3. We've done a lot of characterization work with the groundwater system out there to support our modeling. That's our predictive tool. We also, characterize the groundwater quality, which is critical to evaluate our ability to treat the water and how we can treat that water, put it back into the aqueduct. Then we've also been, collecting some data to monitor what's happened as we've recharged water. As everybody recalls, we put in something on the order of 60,000 acre feet of water already out there. So we've got the ability to monitor what's going on with the subsurface as we recharge that water. We've been looking at that at a high level to see what we're learning from when that water moves down to from the recharge basin down to the groundwater. So that's kind of a summary of what we've done over the last several years, and I'm happy to answer the questions.
Just a question, just your general comment. The number of wells we have, over 20 wells, it appears like that'll deplete that recharge basin fairly fast. Do we need that many?
It's a good question. Because there's, like I said, these estimates of how much these wells how much they can pump are estimates, assuming that each one of those wells is just the only well operating. And so we've modeled all of them running to all 27 wells at one time. And our estimate right now, based on the last set of runs from the model, is that our pumping capacity, our total well field capacity is something on the order of 75,000 acre feet per year. So I think 27 wells, and that buffer I think is needed. You're going to need some redundancy in your well field. So you may not need actually 27 to physically get that water out of the ground, but you're going to need to have some redundancy in your well field. The wells aren't all going to operate perfectly when you go to fire it up in the future. So 27 is the number I think that we're going to land on and build out there. And there may be times when we'll operate parts of the well field if the call from Metropolitan for water is at a level that allows us to draw in some of the wells. So I think 27 is a good number to support the idea that when all the wells are pumping, you're going to see a lot of drawdown on that side.
Yeah. It just, for years, I went between Wasco and Paso Robles. You see the oil fields there, it's over maybe a small, I don't know if it's thousands of acres or hundreds of acres. And some of those wells are just feet from each other. And I just wonder, I guess different depths, but it just makes no sense how close they are.
Yeah, that's a good question. I mean, I'm not an oil field geologist by any means, but I've been through that area and I see all those little things pumping down like this, and those wells are really close to each other.
Yeah.
And but they could be at certainly different depths or something. Sure.
Thank you.
So I have a question. Would we be ever running all 27 at one time?
I guess it would depend on if there was a situation where Metropolitan, we had stored a lot of water and Metropolitan wanted to say we need 70,000 acre feet to maximize the goal of the project in order to get that water out. Yeah, we would try to fire up all 27 and get that done in a year. Our model suggests that over the first year, we'll be able to sustain the well field operating at nearly its starting rate, and then after that, if they ever wanted to run a multi-year recovery cycle where they recovered for over 1 year, then the well field's going to really start to drop rate-wise. So yeah, it would just depend on how much water Met needed out of the ground in the time they wanted it.
So even with that 10% leave behind in us,
Yep.
in us banking that water out there, you see that cone of depression?
Yeah, what'll happen is, unless you recharge and recover back to back, which is not all that common in operating groundwater banks. Typically, there's a lag between when you recharge the water and when you recover the water. That mound that develops is going to dissipate and get back to pre-recharge conditions.
I guess that's why, it's so important to continue to recharge. And to keep that continuous recharge.
If you can, yeah.
Thing, because all of a sudden you take a year where you don't.
Yeah.
Or two, you're gonna really see it.
The simulation that Metropolitan provided us to simulate had a 1 year lag between finishing of the recharge cycle to starting the recovery cycle. You know, anticipating that would be a norm that they might see in the future. There might be times where there'd be a swing in the climate in a way that it suggests they want to get it out right away. And if you started with a mound there, yeah, you'll have a little bit higher capacity in the wells.
Okay, is there any further questions from the board or staff or anyone that may be listening in? You're welcome to make comments or ask a question. Okay, there's no board order, this is for information.
I have a question.
Dr. Ferris.
You ignore me now and you make me make the motion before, I don't know. You know, we're planning a phase 2 out there.
Heard that.
And I was listening intently to what you're saying about how the well fields and how much, you know, we're looking at trying to get 70,000 acre feet, and then in subsequent years that would fall. If we put a similar phase 2 size in that area, how is that going to impact our ability to get the water out, and how much? I know you haven't done all those studies yet, but it would seem to me from what you're saying that would have an impact on the amount phase 2 could do, and may have an impact on what we're doing on phase 1.
It certainly, if it was really close, it certainly could have an impact. We would have to study that, and we've done some we've worked with Matt and just a little bit on this, and just done some very, very high level looks at that. But you're right, we would have to study that. I think if you butt it up right next to it, yeah, we'd have to, add that to the groundwater model and study to see what impacts. There definitely would be an effect. But I think you'd be able to operate 2 banks relatively close and still get a lot of capacity, storage and recovery capacity out of it.
Thank you.
Okay, yeah, thank you.
Thank you.
You do a very good presentation.
Thank you.
Appreciate it much.
Good job, Tim.
Outstanding.
I think Julia has a question.
Just a quick question. What's the approximate distance between each one?
Good question. We started out at about a quarter mile. So we're roughly spaced. They're somewhere shorter, somewhere longer, but yeah, roughly a quarter mile.
Okay, Dr. Nice, back to you.
Yes, thank you. The committee also discussed and will recommend approval the notice of completion for the High Desert Water Bank well drilling package number 3. And engineering manager Livesay will have a report for us.
All right, thank you, Director Dias. Good evening, President Lane and members of the board. Fairly brief item here. So you just heard about drilling package number 3, the successes that we've had out there. Bakersfield Well and Pump is completed with all the work associated with drilling those wells, and they've mobilized from the site. We're satisfied with the work that they've done out there and the completeness of the work under contract. One quick note, due to quantity adjustments, as Tim was describing the way the well is designed after getting all of the information from the field, the quantities that they bid on sometimes vary from well to well and change from the original bid amount. So due to some of those quantity adjustments, the overall project value has come in about $584,000 under what Bakersfield's original bid was. And so, fairly good news there. But at this point, they're all done. It's appropriate to file the notice of completion. After that's filed for a period of 30 days, we would be able to release that final retention payment that General Manager Knudsen mentioned earlier. That amount would be $558,400.50, as long as no liens or claims are filed against the contractor by subcontractor, material supplier, etc. So the recommendation of the High Desert Water Bank Committee and staff is that we file the notice of completion for this project. Happy to answer any questions that you might have.
Okay, on page 34, we have a motion motion, 8B-2. We have well, we don't have a motion, what is the motion?
I'll be happy to make that motion, Mr. President.
We have a motion from Director Parrish. Second from Director Van Dam. If there's no further questions or comments, Madam Secretary?
Audrey Miller,
Yes.
Robert Paris,
Yes.
Jay Tremblay,
Yes.
Keith Dias,
Yes.
Drew Mercy,
Yes.
Gary Van Dam,
Yes.
George Lane.
Yes. Yep. Motion carried, yeah, thank you.
All right, good job, Justin.
And that would include our report tonight. Thank you very much.
Yeah, thank you, Director Lannis. Now that'll bring us down to, General Manager's report, item number 9.
Yeah.
Matt?
Yeah, thank you, President Lane. So fairly brief GM report. We have a lengthy closed session this evening, so get through this. The next meeting, we'll have a full update on water supply and customer demands. But you can see on the screen, we have a few upcoming meetings. The Antelope Valley State Water Contractors meeting here at AVEK is this Thursday at 6 p.m. We have the optional AB 1234 ethics training for all directors scheduled for Tuesday the 19th from 3 to 5 p.m. And attorneys Tilman Kim and Jim Markman will be here in person to provide that training. We have the Antelope Valley Watermaster Advisory Committee meeting next Wednesday at 10 a.m. on Zoom or in person at Court Sale Water District. I think we have one Director Mercy, attending the CSDA annual conference at the end of the month. We have a monthly Watermaster meeting on the 27th here at AVEK or on Zoom. So at the next board meeting, AVEK board meeting, we'll go through that agenda in detail with the board and get direction. And then we have a Labor Day holiday coming up on the 1st of September. So, like I said, brief GM report. That's all I have unless you have any questions.
Okay, there's no further questions, Matt. We'll move on to director's reports. Attorney's reports.
Nothing to report, President Lane.
Any requests for future agenda items? Okay, we do have several closed session items regarding CV communities, community facilities district in Acton, and we have Eastside Water Bank, and we have state water transfer possibility with
West Side District
West
and
Side
Five
District.
Brands.
It looks like there's several districts there.
Yeah.
Okay, so the motion would be in order.
I'll move to go into closed session.
We have a motion by Director Van Dam.
Second.
We have a second. Director Mercy, Madam Secretary.
Audrey Miller,
Yes.
Rob Paris,
Yes.
Jay Tremblay,
Yes.
Keith Dias,
Yes.
Drew Mercy,
Yes.
Gary Van Dam,
Yes.
George Lane.
Yes, motion carried. Take a 5-minute break.
Until then, we're going to talk about item A first, so if you could hang tight.
I need to call.
Yeah, everybody's out.
Oh, I'm sorry. No, I didn't know I had to do that. I'm sorry, Matt.
Hey, thanks, you guys.
Well, I know what you're on Facebook, I'm not, there's just a Facebook group, so I'll reach out, so you get in contact with both of them. That's what I tell them, all of them, to me, go like, this is the best, you know, I just follow when you get there. Good to see you too. I have that battery card for one more time. See? See, Ruthie.
That's something.
Good job, Rick. You're good.
Okay.
I didn't know I had to call them.
Interesting. Seven, 3, 2, 1, 1, 5, 7, 7. And ours, Zorio,
Quarter now.
775, 398, 388. I told her it's 630.
Okay.
They're way out.
Think like if they put in another 10 miles, we put it.
Good night, Julie.
10 miles that way.
Good to see you. Have a good night.
We bought like 1,500 acres.
Yeah.
1,500 acres. Definitely want to go to phase 2, right up at the offset.
Yes.
We should, I'm gonna, we should.
Yeah, this sheet will knock it down, down low.
Like the dark hemorrhage, we have all those.
Yeah.
We have about 300.
You know what? Since those, you know, they calculation, shouldn't be able to.
So they asked, did you get that letter about 6 months ago? They said, but you're just not that anymore. You know, they, first they had us back to every other year.
Right.
Less we pay for it. So I said, fine, do it, I'll pay, you know. And then they just said,
We did.
the settlements will serve you, which is bogus, because they did a good job.
No, I know, yeah.
They did a good job.
But that was the cheapest.
So we have,
Right.
we started to stop being just over 2,000.
We did pretty good, lost.
Oh, no. Almost been stopped.
And that was great. All things. I think we want because he called me first. The second call to his boss. Talk to them and get it.
Right.
No, they didn't, but they got their
That's
job.
what they're hard to get.
Oh.
Yeah, well, we got.
We had 3 wells with
Very reasonable. That last
2
one,
years ago.
also they
2 years ago. We had 2 of the rivers. Well, the one was,
So they had 4
horse, and then another one. So that was 200 horse. And they had both there. So I got a lot of houses, you know, so I guess, our search.
Hey, I spoke to him.
Ridiculous.
oh, yeah, they're terrible. Whenever I see them, I'm sorry, I think we're gonna make out, we just turn the water on.
I didn't see that all the snows.
I know, and I was, they don't mess the travel.
So they have their cattle meeting, the farmer.
First.
21st.
They're
Okay. I wanted to go to that was pretty interesting.
Yes, they do a good
To
job.
kind of catch up on that.
Yes,
Maybe send me a text with
I
that.
will, I wanna verify it, but I think it's 21st.
Okay.
Yeah.
Sounds good. Everything else good?
Yeah.
Hi, Julie.
Okay, Julie.
Hi, how are you? Oh, I love little, I have all boys.
Anyway, all right, sport meeting, guys.
Granddaughters?
Yeah.
I can't wait.
Is that anything for the daughters or my?
Aww. They are so cute. Your daughters were like Princess
Maybe
or
it's
what?
Misty's.
Oh, Misty.
That 15,000 I got for ground. So in case you ever need a ground,
Okay.
we're good,
Hmm.
but this is her little boy.
Oh, how cute. I love that. What's his name?
Brody,
Oh,
Brody.